Right, good to go.
Okay. Good morning, everyone, or good afternoon, depending upon your time zone. Thank you for taking the time out of your busy schedules today to join Pine Environmental and Guideline Geo as we present to you this webinar pertaining to ground penetrating radar solutions from MALÅ, as well as the MALÅ controller app and the Malavision software. If you have any questions throughout this webinar, please enter them in the chat section and we will answer them at the conclusion of the presentation. Also, a recorded version of this webinar will be made available to you within the next 2 weeks. Go ahead, next slide, Daniel. My name is Brian Rollins, and I am the Territory Sales Executive for Pine Environmental, covering Southern California, parts of Nevada, and Hawaii. I am based out of the Fountain Valley branch location in Southern California. In attendance as well today, but not presenting, is Maurice Eddy. Maurice is Pine's Director of Operations and Sales for the NDT and RVI product lines. That's the non-destructive testing and remote visual inspection. Pine Environmental is a proud channel partner to many manufacturers in our industry, including Guideline Geo. With our large presence throughout the United States and Canada, we help provide our customers with access to Guideline Geo's diversified portfolio of MALÅ GPR products for rental as well as sales. Go ahead, next slide, Daniel. Many of you are probably very familiar with Pine, but for those who are not, we are the largest professional service company providing rental equipment for environmental monitoring, non-destructive testing and evaluation, continuous emissions monitoring, as well as a provider of field and safety supplies, or PPE. We have the largest stock of environmental test and measurement rental equipment throughout our many warehouses across North America. We are committed to providing technical and application support on our wide range of products, and we are committed to making the availability of and access to that equipment second to none. Go ahead, next slide, Daniel. At this time, I would like to introduce our keynote speaker today, Daniel Laro. Daniel is the GPR manager from MALÅ North America. Go ahead, Daniel. You can take it from here.
Thank you, Brian. Yep, my name is Daniel Laro. I'm the North American GPR manager. I've been with Guideline Geo for almost 8 years now. I love helping customers understand and work with ground penetrating radar and work with Pine Environmental to provide equipment across the United States. So today we'll be talking about MALÅ product, but Guideline Geo is comprised of two brands, MALÅ and ABEM. Today we'll focus on the MALÅ product, and I'll break the ice for anyone new to ground penetrating radar and in particular utility locating. Guideline Geo is a world leader for near surface geophysical solutions with a 100-year history to back this up. ABEM and MALÅ, our two well-known and world-leading brands, are developed with Swedish technology. We house our own research, development, and production in Sweden. We are in close connection to partners around the world to drive development and innovation. Here in the U.S., our main warehouse and repair facility is located in Charleston, South Carolina, where I reside. We also have other offices based in Denver and Salt Lake City. Our headquarters globally is located in Stockholm, Sweden, with production happening in MALÅ, Sweden, and R&D in Umeå, Sweden. Guideline Geo has a long history in geophysical instruments. Along the timeline are some key events that have transpired over the years, including the merger of MALÅ and ABEM in 2013. Since 2013, we have had strong strategic growth in key markets around the world with a focus on utility locating. Here are some of the solutions we offer. MALÅ offers GPR. ABEM offers seismic, TEM, and resistivity equipment. Again, today we'll focus on the MALÅ GPR. Okay, we need to first identify the issue and why GPR is a key part to the answer. Buried utilities are everywhere. Some utilities are inching towards being buried for a century, while miles and miles of new utility lines are laid every day. The problem comes when these utilities have not been documented the proper way or have been buried so long no one remembers where they are. Even existing utility maps can be wrong. And with these mistakes comes the heartache of striking a buried utility, costing thousands of dollars to fix and the potential of injury to an unexpected worker. Ground penetrating radar can help avoid these disasters and detect these utilities before digging into the subsurface. Let's talk about what GPR is now, with some basic theory to go along with this to give everyone an idea of what exactly our GPR is doing. So, what is radar? Radar is an acronym for radio detection and ranging. A transmitting antenna sends out a radio wave that, when encountering an object, gets some of the energy diverted back. This energy diverted back is recorded by the receiver antenna. With this information, we can determine if there's an object there and determine how far away it is. In essence, this is how all radar functions. The first useful radar systems were used in free space in the air, primarily for military applications. Navigation of aircraft and ships, detection of enemy craft and positioning, weapons guidance, and during World War II, Germany, France, Great Britain, and the United States all used radar to navigate their ships, guide their airplanes, and detect enemy craft before they attacked. So what is ground penetrating radar? GPR is a technique that employs high frequency pulsed radio waves, usually between 30 and 2300 megahertz, to acquire subsurface information, to map metallic, non metallic structures and features buried in the ground or in man made structures. It does not function like an X ray, but more like a fish finder. Some subsurface features which may cause reflections include man made objects such as utilities, underground storage tanks, road construction layers, archaeological remains, burials and hidden objects, and natural geologic conditions such as changes in soil composition, supporting layers, ice, groundwater table, bedrock, boulders, voids, and more. The transmitter from the GPR emits a train of electromagnetic impulses, which propagate through the media or the soil. Reflection occurs where the electrical properties of the subsurface materials change. The receiver picks up this backscattered signal, records it, and displays it on the computer screen. If we look at the animation on the right, we can see a simulated radar wave traveling through the ground. Once this energy contacts a pipe, some of it is diverted back up to the receiver antenna and is recorded, while what's left may continue traveling downwards. The radargram we're looking at, which is the gray screen or the gray box there, is comprised of many pulsed radio waves sent into the ground. The resulting image is showing a utility in the radargram. We call that beautiful hump there a hyperbola. We can also see a red marker was added to this hyperbola to indicate exactly where this supposed electrical line is. This radar image is a perfect example of what we like to see in the field. Next, let's talk about the parts of a GPR. There are three main components to GPR. First, the cart, which helps you push the antenna. So second would be the antenna itself, which can be of varying sizes depending on the frequency of the antenna. At the top, we have a 750 megahertz antenna. Underneath that is a 450 megahertz antenna. Then we have a 160 megahertz antenna, and the biggest of them all, an 80 megahertz antenna. The last part of a GPR is the data collector, which in our case is a tablet. Now, this leads us to the Easy Locator Core, our latest innovation for the GPR market. For nearly 20 years, the Easy Locator series has been used by professionals worldwide to help find and locate utilities and the like in the subsurface. The Easy Locator has seen many changes since 2003, incorporating the latest technology with each revision. The latest of the series being the Easy Locator Core. The Easy Locator Core boasts some of the best quality data in the market. Having pushed beside many competitors, the Easy Locator quickly stands out from the rest. With interpretation support from MALÅ AI, which we will see later, and a powerful post-processing software called Malavision, Guideline Geo has developed a workflow that is quick and intuitive. Easily adds centimeter precision to underground targets with a total station or RTK GPS that seamlessly connects with the radar. As you can see in the photos, the Easy Locator Core has quick releases on the handles and wheels to make transitions in the field quicker than ever. The small wheel setup is optimal for surveys in areas that are flat and areas that are hard to reach. If we look at the photo at the bottom right, we can see that the wheels come off with a push of a button. The batteries to power the instrument are contained within the IP65 rated antenna body. Two batteries can last up to 8 hours of continuous runtime. They are also hot swappable, and the system can stay powered on with just one battery. We also offer a more rugged solution to use during surveys, the RTC Mini. An upgrade from the original RTC, this cart boasts many improvements provided by customers over the years, and we can take a look at those on this next slide. We've incorporated RAM mounts for GPS stabilization and our tablet holder, changed to ski-like straps for adjusting ground clearance, and moved to nylon nuts for securing the wheels to the cart. There were also improvements to the handlebar connection. In this next video, I'll show you how to transition from the small wheel setup to the RTC Mini. It's a pretty quick transition there. Next, we'll talk about the MALÅ controller app. The Easy Locator Core is controlled by a Samsung tablet that wirelessly connects to the antenna. We then utilize an app to run the instrument. This is called the MALA controller app and is seen at the top right of the tablet. After clicking the app symbol, we are brought to the main page of the app. We can then start a 2D project, 3D project, manage past projects, and go straight into Malavision, our post-processing software. You will also notice at the bottom left, after establishing a connection between the tablet and antenna, the EL core text is seen and the status of the batteries. There is also a GPS symbol which is showing no pause or no position right now. The GPR does contain a GPS inside of the antenna for location support. If we now turn our eyes to the top left of the tablet, we will see three lines, and we'll click that menu option now. After clicking the three lines, we can see our menu options. If we started a measurement, we can always go right back to it from this menu by clicking measurement. There's also a help and support page where you can write up into us with any problems or concerns directly from the tablet. You can even attach a project to the support ticket. That menu also contains guides for connection issues and a quick start guide. Next, we'll look at the settings menu. Here, we're able to determine how much data we want to see on the radargram. Right now, it is set for 25 feet. We may not be able to penetrate down to 25 feet, but this setting will give you a complete view of the full radar window in the radargram. You can adjust this setting by sliding the circle on the bar. We can then change how we want to trigger the antenna to collect data. In this instance, we are using a distance trigger, meaning we're using the wheel on the RTC Mini to do so. We also have an option to choose whether you want to use internal GPS or external GPS or a total station. Now I'll switch over to the radargram and look at the menus there. On the main page, if we select 2D project, then start the project and start collecting data, this is what we'll see on the screen. On the right side of the screen, you can see a menu bar is pulled out. This menu bar can be shown or hidden with the arrow. I have then selected all of the options we have while running a survey. These menu bars are shown to the left of the screen. It's important to note you can move these menu bars anywhere on the screen with the four arrows. You can also X out of the menu bar to remove it from the screen. The top menu bar that we're looking at here is the filter menu. This is where gain, contrast, and other visualization options are stored. These control how the data looks on the radargram. Underneath that menu bar is the AI object detection menu. This is where we determine a threshold for the AI to detect and mark objects for us. I will show a video of this happening in real time later. The next menu bar is our annotations menu. This menu is used to take screenshots, add photos, voice notes, and text notes. This is very helpful when in the field to help remember what your surroundings were or important details of the survey. The last two menus are marker menus used to determine shape, size, and color of the marker you are using. The marker colors also correspond to the industry standard for utility locating. If we click on a marker that is put atop a hyperbola, we then see the details of that exact marker. Depth and distance is shown with white dotted lines, and we can also add annotations directly to that marker, change the color, set the depth, and do a hyperbola fitting. This view of the radargram is with all menus off and hidden, much like when looking at a picture on your cell phone where you can pan in and out of the photo with your fingers. We can also do the same thing with the radargram. This allows users to customize the depth and aspect ratio they want to see on the fly. Next, we'll see a video of the MALÅ AI in action. As you can see in the video, as data is being collected, the MALA AI goes to work, marking out targets it thinks of is of interest. There is a threshold you can set that controls how many markers are being put in the data. You can either work with the markers or without. It's up to the user. Malavision is our proprietary post processing software. It is used to visualize your data in a simple way. We can create reports, export coordinates, and share our findings. I'll now show this software live. So as you can see, it is a browser-based or web-based post-processing software, and you will have a login and password to get in. After loading in and logging in, you're brought to the splash screen. And on this splash screen, we see new project and open projects. So anything we've done in the controller app, what I was just showing you, we can export directly into Malavision, and that will go into open projects. We can also create a new project with old data we have or with data from competitor systems. So if I click new project, I can name the project, and this is where I would drop my files in to start exploring them. Also on this page are updates. So this, because it is web-based, we can update this periodically with customer feedback. And we also list what was updated here. Now, I already have a project loaded I want to show you guys. So I'm going into open projects. And when you are in the projects folder, you have the ability to create another folder where you can store multiple projects in one folder. And as you can see, I have cemetery data, utility examples, and then I have some freestanding projects here. So I'm going to go into utility examples, and I want to show you guys a data set called Park Circle. Now, upon the data set opening up, we are taken to a 2D view of the data. I can scroll into this data, I can scroll all the way out, and I can move it around if I'd like. Now, if I had more than one profile in this particular project, it would be listed here. And I could scroll through these profiles with the page up and page down key on my keyboard. We also have a menu bar over to the right, and we have a couple of filters that are automatically put in or added to the project when you import them in. That's DC offset, AGC, and background removal. Those are automatically put onto the project when you put it in, but you can also add some other filters that we allow here, or you can remove them all. We have display effects, which will change the look of the data. So contrast and gray balance, brightness. And I really like this one, the aspect ratio, where you can stretch the data out or zoom it back in. And then we also have a different colors that you can change on the radargram. And if I right click the slider bar, it brings up the different colors we can change to. Next, we have interpretation. This is where I can add in markers myself, but if I've put markers into the controller app when collecting data, like I've done here, um, they will automatically import in. But if I wanted to add in some more markers, I can do that right here. And if you hover over them, you can see that they also give you the industry standard for what that color means. We can change the type of marker, we can change the size of the marker, and we can switch markers on or off, delete them, and do a lot of different things with those markers there. Next is analysis. This is where we can toggle the vertical units over here to the left. As you can see, I have it on depth, but I can also change it to nanoseconds if you like that. This is also where we set the velocity and the time zero. And we have MALA AI on Malavision as well, in case you have a unit, an older MALA unit that doesn't have the AI feature, you can upload to Malavision and use the MALA AI here to detect different hyperbolas. And this can be collapsed as well. And then we have this big, beautiful radargram set here to look at. Our next view would be the 3D view. So because we have the internal GPS, I believe I was using external GPS on this one, but even with the internal GPS, you're able to look at where you've walked and you're able to have this really nice 3D view of the data set. Now, because we put in markers, those markers have GPS coordinates on them. And once Smalavision sees that and sees it's the same marker type, same marker color, it starts to try to create a polyline. And we can see that's what's happened here with these two lines. Our next view would be the sitemap view. You can see this is a classic Google map. And if I zoom in, you can see we're at literally Park Circle. We also have a satellite view where you can zoom in and look at that. And you can do a little turnaround, whichever view you like. We also have, if I pull this menu out, uh, an open layers framework as well, which gives you the Mapbox view of this site as well. I like Mapbox because you can literally zoom really far in, whereas Google doesn't allow that. One of the cool things about Google, and I'll go back to it now, they have a street view. So because we were alongside a road here, we can go into the street view and see where these markers were placed in street view. Now, all these views are awesome and cool and good to look at, but what can we do with it, right? So if you look at the top right here, there is a camera and a little snapshot photo button here. And if we click that, it takes a snapshot of this 2D data. We can also do that for the 3D data is click this snapshot button, take a photo of that. And we can do that in the site map as well, and we'll take a little snapshot of that. Now, once those snapshots are taken, they're stored down at the bottom here, uh, and we can click on these, and I can do a little free draw if I wanted to circle something or put a little arrow, just whatever I wanted to do there, and I could save it, but I'm going to clear that out. All right. Now that I've done my interpretations, I have my photos. My next step would be to create a report. If we click create report, we are given a blank report that we can fill in. We also can add in these photos, and you can see they're numbered 1, 2, 3, and they're added to the bottom of this blank report. And what I like to do is go ahead and export to Word. And this will allow you to change the size of these photos and maybe put it into a template that you already have saved for reports. The next thing I could do after I'm satisfied with the report is export my data. So I have a couple of options here. I'm going to open them up. I can export all of the GPR data I've taken. I can also export my interpretations, meaning I can export my markers, my polylines, markers and polylines, profiles with GPS altitude. Now, let's say I just want to take my markers out. I can export those as a text, a CSV file, KMZ, or a DXF. Now, let's say I want to export as a DXF. I can click on this wrench here to show the export settings. And now I can choose my local projection that will go into my AutoCAD or GIS applications and know that it has the correct projection for that application. And I can also export any images or any of the annotations that I've taken here as well. And we can export all three of these at the same time and they'll go into a zipped folder. So I believe that's the end of this presentation. If anyone has any questions, I think we've asked for you to write them in the chat. Um, let's see if we have anything there, Brian.
Okay, let's see here.
Nope, no
Hmm.
questions, which is fine. I think if you have any questions, Brian can be reached at Pine Environmental, or you can reach out to me here at Guideline Geo.
Okay, we have
Um,
a question here. What are the depth limitations?
sure, that's a great question, right? We get to ask that all the time. So GPR uh, limitations are based on soil conditions. So depending on your soil conditions, will give us our depth limitations. And it's hard to say that with not knowing where you're from, but in perfect soils, I would say this easy locator core can easily go 25 feet, right, in perfect soils. In moderate soils, I would say a good estimate is about 10 to 15.
Okay, we have another question. Has the technology progressed for conductive soils?
So conductive soils are, well, let's take it back. GPR theory hasn't changed, right? And the way that GPR conducts itself by sending a pulsed radio wave into the ground. That's always the same. That's never going to change. And what conductive soils do to electromagnetic waves hasn't changed. But what has changed are the components inside of the radar itself, which help eliminate the noise that could come from conductive soils and try to filter it out a little bit better. So you'll see a big difference between, say, a GPR from even 5 or 6 years ago to the technology we have now. It just performs better.
Okay, perfect. Another question. Limitation in clays with shallow groundwater?
Right. So if perfect soil is sand, the worst soil I could think of is clay, wet clay. Right. So dry clay, we can work with that. Wet clay is almost a no-go, right? So it's going to depend. Soil changes so much that you may have clay in one area that's dry and then wet clay in another area, and then with a high uh, water table mixed in with that could definitely uh, do some damage to your data. I think we have a gentleman with his hand raised there. Uh, Bob Elster, is there something you wanted to ask?
I think he needs to be unmuted.
Okay, I'll do that. Yeah, I don't think I can unmute him.
Okay, Bob, if you could type your question in the chat window, that would be much appreciated. Okay, well, are there any other questions at this time? Okay, if there are no other questions, we would like to conclude this webinar. And we thank you, Daniel, for this excellent presentation you put together.
Thank you.
We'd also like to thank all of you for joining us today. And as mentioned, we'll make available a recorded version of this webinar for all those who have registered. If we have no further questions, we'll go ahead and end this. Thank you all and have a great rest of your week.
All right. Thank you, guys.